All right, so let's finish up this numbers unit by talking about opposites and absolute value of numbers. And both of them are best described by looking at where they show up in the number line. So if I were to look at, for example, some number, and let's just call it A, because I don't know what it is. It could be a polynomial number, it could be a rational number, I don't know, but it's some number A. The absolute value of A is an evaluation of how far it is from zero. So absolute value, and it's written this way inside of these bars, absolute value of A means how far is it from zero, or the distance from zero. Now, a lot of us learned for absolute value, just change the sign inside or make everything inside positive, which works most of the time as a trick, but in algebra, it's really important that you begin to understand exactly what you're doing when you do that. It's not just changing the sign, it's really just saying how far is something from zero. And clearly, nothing can be negative units away from zero. Distance is measured in positive units. And so the absolute value means how far is it? We don't care about the direction you're going, we just care about how far. And so if you look on the other side at negative A should be exactly the same distance away from zero as positive A. So the absolute value of negative A is going to equal the same thing as the absolute value of positive A. Okay, that makes some sense. Then the other phrase the other part of the title, so we've talked about the absolute value, but what does it mean an opposite? Opposite really just means opposite. It means on the opposite side of zero in the same distance away. So if I want to evaluate positive A, or the opposite of positive A, the opposite of positive A is going to be negative A. And the opposite of negative A, it works in both directions, would be positive A. So the opposite just means the sign change of moving to the other side of zero the same number of units. And this is the notation I'm going to use as we work through these problems. And when you solve them by using the number line, which is one of the instructions you'll be given, I want you to use this loopy arrow to show the opposite, right? The opposite of some value, in this case A, and I want you to use this little bracket to show the absolute value. So let's look at and talk about what happens with our four different number types. So we know that we have integers, which I'd like to spell right, and we have rational numbers, we have radical, and we have polynomial. All right, so in this unit, we're going to care most about what happens with integers and rational numbers. Radicals and polynomials can be evaluated in exactly the same way, but the special cases that go with them, we're going to save and teach during sections that cover just those types of operations, or those types of numbers. So let's look at what happens to an integer. Find the opposite and, well, let's put this instruction above because it's the same instruction for all of them. Find the opposite and absolute value for the given number. Okay, then I'm going to use an exact value. So for the integer, let's choose negative 7 for my integer. Well, I'm going to start with just negative 7, right? Because that's the number I'm evaluating. So negative 7 is the number I'm evaluating. Well, the opposite of negative 7, if I go this far on this side of 0 and then go the same distance on the other side of 0, the opposite of negative 7 equals 7. So the opposite is 7. Now what's the absolute value of negative 7? So what I'm asking is, what is the distance from 0? Well, the absolute value of negative 7 equals, well, how far is it from 0? 7 units. So this is how you're going to answer these when you're asked to answer them using the number line. Let's do the same thing with a rational number. Let's say 3/5. Normally you don't want to use that diagonal line when you're operating with a rational number, but if you're just writing a number down, that's totally fine. So this is a positive 3/5. I'm going to place it on the number line. So the opposite would be negative 3/5. So that one is answered. And actually this is the one I want you to circle. I circled in the first one, I circled the -7 as sort of a example, but I want you to circle 7 because you're telling me that 7 is the answer here. Now, how far is 3/5 from 0? Well, clearly 3/5 is exactly 3/5 units from 0. So you're done. Let's do it with a radical number. Let's choose the square root. Well, if you get a perfect square, so say the square root of 25, that's easy, because really the square root of 25, or let's say negative the square root of 25. Negative the square root of 25 is at -5. So that's super easy. But what if you don't get a perfect square? What if you get something kind of ugly like -2√3? Well, -2√3 actually has a value. If you put that in a calculator, you can estimate it out at a certain decimal value. So let's go ahead and put -2√3. So it has, a value that goes on the number line. And then the opposite of -2√3 is positive 2√3. And you would circle that. And then how far away from 0 is -2√3? Well, the absolute value of -2√3 equals 2√3. So whatever that number is, it's some decimal, it's some irrational number, but it's definitely something that can be graphed. And what gets tricky is when you're looking at graphing polynomials on the number line. Because what if I'm trying to find the opposite of -2x? Well, it kind of depends what x is, right? If x equals -4, then -2x equals +8. If x equals +2, then -2x equals -4. So it's kind of hard to tell where it goes on the number line. So we're not actually going to do that. Okay, so you certainly are allowed, if you want to, you could say, well, suppose x equals 1. You could define it. If you say if x equals 1, then -2x is at -2 on the number line. The opposite would be +2. And the absolute value of -2x when x equals 1 equals +2. So it can be done, but it's much less probative, and it's much more like it just depends on whatever the value of x is. So these are the evaluations you would do for opposites and absolute values of numbers.